Welcome to today's class. In today's class, I'll be showing us how to calculate the relative atomic mass of elements, the relative atomic masses of elements from the concept of isotopy. So, for example, X is an element which exists as an isotopic mixture containing 90% of X mass number 89 and 10% of X mass number 41. Calculate the relative atomic mass of X. Remember, in the periodic table, we normally represent elements in this form, where X represents the chemical symbol of the element. The bigger number on top represents the mass number of the element, while the smaller number down represents the atomic number of the element. So a phenomenon whereby we have atoms of a particular element having the same atomic number with different mass numbers is what we refer to as isotopy. Okay, so going back to the equation, we have to calculate the relative atomic mass of the element X under consideration. For us to calculate the relative atomic masses of elements, we use the expression relative atomic mass is equal to capital letter A times small letter a plus capital letter B times small letter b all over 100, where the upper case number represents percentage composition, and then the lowercase number, or letters rather, the lowercase letters represent the mass number. So, by substitution, A will represent the first isotope, this isotope, and then its proportion. B represents the second isotope and the proportion. So we substitute capital letter A represents 90 times small letter a represents 39 plus capital letter B represents 10 times small letter b represents 41 all over 100. Always note that the summation of the proportion should give us 100. That's why we have this 100 here. So 90 plus 10 giving us 100. Alright, 90 times 35 will give us 3,510 plus 10 times 41 giving us 410. Divide by 100. If we add 3,510 to 410, that will give us 3,920 divided by 100. Of course, the first zero will cancel this out, and we have 1 0 remaining. So we move 1 decimal point to the left. We fix it there, and that will give us 39.2 or 39.20. So the relative atomic mass of X is 39.2. We take the second example. A given quantity of chlorine contains 75% chlorine 35 and 25% chlorine 37. Determine the relative atomic mass of chlorine. So still using the same formula, we have relative atomic mass equal to capital A times small a plus capital B times small b all over 100. And by substitution, capital A is 75 times small a is 35 plus capital B is 25 times small b is 37 all over 100. Alright, 75 times 35 will give us 2,625 plus 25 times 37 will give us 925. Divide by 100. And when we add 2,625 to 925, that will give us 3,550. Divide by 100. Once again, the zero down, cancel the zero up. We are left with 1 0 down. We move one decimal point to the left, and that will give us 85.5. Therefore, the relative atomic mass of chlorine is 85.5. Thank you very much for your time. If you just come across my video for the first time, please do endeavor to subscribe to my YouTube channel. Keep watching, like, comment, and share. Thank you.